Hello, our video today is on polarization. So let's get started. So we know that whatever we see, it's because of the light reflecting from that surface. So it is the electromagnetic wave, the visible part of that electromagnetic wave that is reflected off the different surfaces. It makes us see them. This is a usual electromagnetic wave which is made up of both electric and the magnetic field. So if our eyes can detect only electric field, when you're seeing something, what you're detecting is only the electric field component of that light. So let's say there is this, you're sitting in a room and there is this bulb. Okay, so this bulb here is emitting light. This light has an electric field, so this is the direction of the light wave. The electric field component of the light wave is in all possible directions. So the electric field component of the wave is in all possible directions. So this light wave is an unpolarized light wave because the electric field is not restricted to any one direction. But if this light ray would be polarized, so if I say this light ray is now polarized, the electric field part would be then either restricted to one direction, this is vertical direction, or it might have this direction, horizontal, or it might be restricted in this direction. So if you are restricting by some way the electric field vibrations in one particular direction or in one particular plane, then that wave is called polarized wave. Okay, for example, if I let this light pass through a polarizer, a Polaroid, okay, and then this polarizer has slits like this. So then what it does is it restricts all the electric field vibrations parallel to the slit. So the light ray that comes out would have electric field vibrations only in these directions. Now, if I allow this unpolarized light to pass through a filter which has slits then like this, then the light ray that would come out would have horizontal electric fields vibrations. So now when you are trying to restrict the vibrations of electric field along one direction, that's just is polarization. Now, what changes in polarization? What are you trying to change in polarization? You're trying to restrict the oscillations to one plane or one direction. Okay, just ignore this dot. Now, which kind of waves can be polarized? Only transverse wave. Now we know that electromagnetic waves are transverse. So transverse means when the oscillations are perpendicular to the direction of energy transfer. So if your energy is transferred in this direction and your oscillations are in a plane perpendicular to the energy transfer. So if your oscillations are perpendicular either in this direction or any plane that is perpendicular to x. So if this is x, the entire YZ plane, all the vibrations will be restricted to YZ plane perpendicular to x direction. That's a transverse wave. So only transverse waves can be polarized. Longitudinal waves cannot be polarized. Okay, it shows that a light is transverse in nature. Now, how can light be polarized? One way to polarize a light, so let's say you have electric field vibrations in all possible directions, unpolarized light. Say if we pass this light through polarizers or Polaroids. So we saw that in the previous slide. So if I have this kind of, why I'm doing this again is I just want to solve one of the common exam questions. So the light that is passing through this one will have vertical electric fields. Now suppose I place another filter here. Okay, so I'm just putting another filter here which has horizontal slits. What would be the light that comes out of this? So there will be no light, because we have already cut all the vibrations of electric field and they are restricted to vertical axis. So when you let this vertical restricted polarized light, so this is your polarized light, SOZ, polarized light. So when you allow this light to pass through the Polaroid in horizontal axis, so then no light comes out. Why do you need to polarize it? That in a minute. First, let me just finish. What is the other way light can be polarized? Sometimes reflection also polarizes the light. So for example, if you have a mirror here, okay, and a light ray coming from a source, let's say a lamp or something, which is a torch, for example, this has vibrations of electric field in all possible direction. The reflected light would have reflected light would be polarized, and it would have electric field vibrations restricted parallel to the plane of your mirror. Say reflection is one of the way to polarize or partially polarize the light. You can use Polaroids or polarizers. Some of your polarized sunglasses, okay, some sunglasses are polarized. So what do polarized sunglasses do? So they have kind of, try and make sunglasses here. Okay, yeah, kind of, yeah. So the polarized sunglasses, no, that's horrible drawing. Let me just erase this. So if you have a polarized sunglasses, generally polarized sunglasses, what would they do is they would have vertical Polaroids in them. So they will allow only vertical vibrations to go inside. So if you turn it like this, then there will be no intensity going on in your eyes. Now, why do we need to polarize the light? So sometimes we have this glare. Okay, let me just add another slide. So let's just go. So if you are standing in front of, let's say, some reflective surfaces, okay, you're walking on a high street and there's a light coming from sun that is getting reflected from a surface. Let's say there's a building here, light rays coming from here and getting reflected and reaching your eyes. So this reflected light, you don't want this reflected light, so this would have a polarized, let's say it is polarized in the direction parallel to the plane of this building, so it is polarized like this. So now this polarized light is the one which is responsible for glare. Somebody is going up on a mountain, okay, there's a lot of snow on the mountain, so the light from the sun again goes onto the snow and get reflected and it goes into your eye. So this light, which was not polarized, is now polarized parallel to the surface. So let's say it is polarized, so I'm assuming that this is the surface of the snow, so kind of polarized. So this polarized light is the one which is responsible for your glare. Now if you wear if you have put on some glasses, some polarized sunglasses, which would allow only vertical fields to get into your eyes, so then you would be you will not be blinded by this glare, which is so uncomfortable. So this is one of the reasons of using polarized glasses. Another application of polarized is in 3D movies. Now, what happens in 3D movies is the one side of the glass would have vertically polarized light. It would allow only vertical oscillations to get into your eye. The other glass, the other side of your eye, would allow horizontal. So now you'll have your image that is reaching to your brain will be two images, one with the vertical oscillations of electric field, one is with the horizontal electric field, and then the brain merges them together, and then you can see the 3D image. So these are the applications of polarization. Now this could be one of your exam questions. Explain how a polarizing filter produces a plain polarized light. So you should be pausing it and doing it yourself if you have done that. So how do you think it does? So first you need to explain what is unpolarized light. So an unpolarized light has what? It has electric field or vibrations in all the planes. Now, what does the polarizing filter do? The polarizing filter allows vibration in one direction only and absorbs the other components. That's it. Okay. So you can just define what is unpolarized light. So unpolarized lights has vibration in all the direction, has vibrations in all the planes. Okay. And what does polarizing filter do? It restricts the vibrations. Filters restrict the vibrations to one plane, and absorbs all the other directions, vibrations in other directions. Two polarizers are at 90 degree. What is the transmitted intensity? 0. So one is horizontal, vertical. Let's say this one is cutting it, and then if you rotate it and keep it like this, it is not going to transmit anything. So whatever was going in, it is now restricted only in vertical, so only verticals are coming out. So obviously if you take anything, so nothing comes out, no vibrations are coming out, and so there will be no transmitted intensity. Okay, so that's it. So that's polarization. So polarization can be done only to EM waves, can be done only to transverse waves. When polarization happens, it cuts, as you can see on this diagram also. So it has now restricted the vibrations only in the vertical directions. It is now restricted only in the vertical directions. Okay, so that's it for today. Keep learning. Thank you so much.